This is an example of difference, bless you, of squares. It's going to save you time to know this. And that is if you have A, well, let's just go plus B, A minus B. It doesn't matter which one comes first. Bless you. It's just going to be A squared minus B squared. That's why Logan could quickly say that it's just cosine squared alpha minus 1 squared. And then he did a perfect job of illustrating that this just equals sine squared alpha, but don't forget the negative. Remember, what I do is I don't memorize all those variants. All I know are the 3 main Pythagorean identities, which are based upon the sine squared plus cosine squared equals 1. I always look back at this and I try to manipulate this side to look like that here, which Logan said you'd have to subtract the 1, subtract the sine. So if I were to rewrite this, I would have cosine squared minus 1 equals negative sine squared. So I don't want to hear I just can't memorize this. You don't memorize this. You remember sine squared plus cosine squared equals 1 and manipulate it to make it work for you. Oh, I should have been cosine. Yeah, no, we're good. All right, any questions on that one? Okay, questions on the homework that was due. Yeah, Lizzie.
Well, I have questions. You put an extra credit on Google Classroom. When is that due?
It's never due.
So we can just...
Yeah, you can work on it. It's a really hard one. It was just because you were at the PSAT prep stuff. And so people that actually had the class had to have something to do, so I put up that problem. It takes a long time. I was looking around for people that started it, but no one was in the class. One person got it right.
Oh my goodness. Jorge?
No.
Kyle?
No.
Does Kyle take this class?
So anyway, any questions on the homework? So yeah, there's extra credit out there if you really want to do it. Yeah, it's a tough problem. Number 13.
Oh, I had trouble with this one at first.
So I think you can either go about this the hard way or the easy way. I would prefer probably the easy way. That's my money for it. All right, so we have cosine. I'm just going to call it x because it's easier to write. Tangent x plus 1 times sine x minus 1. Now, what I'm going to say is this looks super complicated. This looks super easy. I don't want to distribute this unless I'm going to look to see if I can simplify this first. Because distributing this to both things would create a long thing that would take, we have a longer possibility to make mistakes. So I'm just going to look at this little section here. And I'm going to notice that I can rewrite tangent. So I'm going to rewrite this as cosine x times, tangent is going to be sine over cosine, and then it's just plus 1. Well, that's going to cancel out, so I really have just sine of x plus 1 times sine of x minus 1, which is a difference of squares, so that's sine squared x minus 1 squared, which is just 1. If we do the same thing we did over here, and move the 1 to this side to get the sine squared minus 1, and move the cosine squared to this side, we're going to see that it actually equals negative cosine squared x. Does that make more sense? Yeah. So I think the big thing is simplifying this first, otherwise it turns into a crazy complex problem that takes a while to solve. Yep, simplify first and then worry about distributing. All right, other questions? Yeah?
What was 69 and 72?
69 was cosine of negative x. So that means I could rewrite that as cosine of x. So it really is just cosine of x, which is the exact same thing as 60, so it would be g.
Oh, you could use sum twice.
Yeah, I said that. I said on several occasions. All right, what was your other question, Pablo?
72.
72. So, yes, it'll just be secant of x, and it'll turn out to just be m, which is 1 over cosine of x. All right, other questions? Those were the duplicate ones. Okay, then let's go into today's thing. All right, we've already done a bulk of what we're going to do today, at least starting out. And that was this exact same problem. That we use sine squared plus cosine squared equals 1 to solve problem. In this example, they said find cosine alpha, given that sine alpha equals negative 3/5 and alpha's in quadrant 2. The only reason why I care about it being in quadrant 2 is I just care which ones are positive and which ones are negatives. All right, that's all that extra thing is. It might say it's between 0 and pi over 2. That would just be quadrant 1. Anything after here is just positives and negatives. All right, and all we had to do is just take that 3/5 and plug it in for our sine. So where we have sine squared, I'm going to have 3 over 5 squared, and then we just solved it. We solved it for cosine, and then we said cosine is either positive or negative. Well, it's going to be negative because it's in quadrant 2. All students take calculus. So quadrant 2 is just sine is positive, so cosine is negative. Do you remember doing this? All right. Before we get into the next thing, I want to put a little note to myself. This can help you, or you might not use it at all. This problem could have been solved a little quicker, just manipulating the formula first. So we know that sine squared plus cosine squared alpha equals 1. Well, at the very end, I want to have cosine alpha by itself. So you can, every single time, plug it in, move stuff around, or we can move it first and then plug in our information from there. So if I want to get cosine by itself, I would subtract sine squared from both sides. So that would give me cosine squared alpha equals 1 minus sine squared alpha. Then I would take the square root of both sides. So cosine alpha is really just 1 minus sine squared alpha. If I would have done all this work, and you can do a bunch of this in your head, right? I can subtract sine from both sides in my head. I can figure out how to take the square root in my head. You could have jumped to straight, hey, this is 3/5. Plug 3/5 in here, and then just go work down. Then you don't have to worry about moving stuff from other sides. It's already done for you. I bring this up because I'm going to use this fact right down here to help simplify it. You can use this every single time. I mean, you can do this every single time and you're fine. This is just a little bit of a shortcut that you can do in your head to make sure it's correct. Okay. So, on that one, I gave you sine. You had to come up with cosine. The ones we're going to do in this one are like this. They give me a tangent value, and they ask for all of the other trig functions. All right? So we need to find the other 5. That's sine, cosecant, cosine, secant, and cotangent. We need to find the other 5. So they say given that tan alpha equals negative 2/3 and alpha is in quadrant 4. Well, since I have 5 different things I need to find, all I'm going to do is circle quadrant 4 and say which ones are positive. If it's in quadrant 1, you're just going to put all positive there. But since I'm in quadrant 4 and it's all students take calculus, cosine is positive. So because I'm in quadrant 4, cosine is positive, and secant is positive. This can help me as I'm doing it, or you can be the type of person that finishes the whole thing and puts their negatives and positives at the end. Either way, you're okay as long as you put this up there and you figure out after. All right. When I need to find all 5, I'm going to find the easiest one first. The easiest one first is just to find the reciprocal one. And who knows the reciprocal of tangent? What is our trig function that's the reciprocal of tangent? Yeah, cotangent. So we're just going to find cotangent right off the bat. That way I have one done and it's correct. So cotangent alpha equals the reciprocal of negative 2 over 3, which is negative 3 over 2. So every single time you should at least have one right. All right, no one should get 0 points on these. Because the first one I'm going to find is the easy one. Our next step, well, if I use sine squared plus cosine squared equals 1, that's not going to help me because I know what tangent equals. So what we're going to do is we're going to go to our identity sheet. And we're going to look underneath the Pythagorean. Do you have your binder?
Oh, yeah.
Yeah, because you're supposed to show it to me today, right?
Oh, I didn't know I was supposed to.
I said to, otherwise you're getting an email.
Oh.
Do you have your binder?
Yeah.
Okay, take it out. So everyone should have their identity sheet on their desk, which you would if you had your binder. All right, you're going to look at your Pythagorean. The 3 Pythagorean ones that are based upon sine squared plus cosine squared equals 1. All right, there's only 3 underneath it that you really have to have memorized. Those are your 3 main ones. You're going to pick the one of those 3. In fact, there's 2 that work on this one. But you're going to pick the one that will work if I know tangent. Can someone tell me the one that you would work with tangent? Will.
The middle one, so 1 plus tangent squared of alpha equals secant squared of alpha.
I'm just going to rewrite that just a little bit. I'm just going to put secant squared alpha equals tangent squared alpha plus 1, but I kept it all the same. We also could have used the cotangent one because we actually know the cotangent value. All right, so we're going to pick one of those 3, and it's going to be based upon which value was given to me. So if I'm given tangent, I'm going to use this one. If I'm given secant, I'm going to use this one. If I'm giving cotangent or cosecant, I'm going to use the other one. If I'm given sine or cosine, I'm going to use that third one. All right, so it tells you what to do next. It says, hey, I'm giving you tangent. Use the one with tangent in it. And now we're just going to replace that negative 2 over 3 with tangent. If you wanted to in your head, you would realize that you just take the square root of both sides. I'm not going to do that right now, but you could have already done that. But we're going to have secant squared alpha equals, instead of tangent, I'm going to replace that with negative 2 over 3. We got to keep the squared because it was tangent squared, plus 1. Then we're going to have secant, let's leave the squared just for now, is going to equal 4 over 9 plus, instead of 1, I'll do 9 over 9. I'm going to go ahead and take the square root right away. So we'll have the square root of 13 over 9, which is just going to equal the square root of 13 over 3. So I have my secant value is square root of 13 over 3. Then I'm going to ask myself, well, if I take the square root, I'm really looking for the positive or negative. Is secant positive or negative in this one? Positive. So we should, I always add a positive to make sure I went through that whole check. So it's going to be a positive square root of 13 over 3. Well, if I have secant, I'm going to find its reciprocal, which is cosine, which equals a positive 3 over square root of 13. And people are going to shout and shout from the hilltops that that isn't finished. If you feel like you need to simplify this, do it. The simplified version would be 3 square root of 13 over 13. I'm okay if you leave it as 3 over square root of 13 in this particular instance when we're finding all 6 of them. In fact, the book will leave the answer in this form. It'll leave it as 3 over square root of 13, and that's because we're going to use it to find more values, and it's a constant plugging in and moving numbers around. That simplifying it at every turn just takes too long and it's a waste of time. So I'm okay if you just leave it as 3 over square root of 13. All right, so now I know my cosine value. Whenever we know sine or cosine, we should immediately go to the sine squared plus cosine squared equals 1. And based upon the thing up here, I could have simplified that in my head just to say that sine alpha is equal to 1 minus cosine squared alpha. All right, but that was completely based upon the sine squared plus cosine squared equals 1. All right, I just solved it for sine instead. All right, we just got to put it in our cosine value. So we have sine alpha equals square root of 1 minus that 3 over square root of 13. Maybe I'll put that in red because I'm replacing it. And we have it squared. If I would have simplified it and put it in there, it would have been a very complex thing to square. But like this, it's pretty easy to go ahead and square. So we're going to have sine alpha equals, and I should probably have that plus or minus so I don't forget about it could be either one of them. I'm going to change that 1 to 13 over 13 because we're going to be subtracting 9 over 13. So that gives me that sine alpha equals either positive or negative. Oh, nope, I squared it.
Oh.
So it'd be 3 squared is 9. Square root of 13 squared is going to be 13. That's going to go ahead and give me 4 square root of 4 over 13. So my sine alpha equals, and I should pick negative because it is in quadrant 4. So that'd be 2 over square root of 13. And once I get sine, I have my cosecant alpha, which equals negative square root of 13 over 2. Okay, questions? Yeah, Will.
How come
Other
you
Will.
take the square root of 1 minus 3 over radical 13 instead of just taking the square root of each of them, like separately?
Because you're not allowed to do that. I can't. You got to think through the whole process of it. If I'd plug in a value here, I would subtract it, and then I would take the square root of both sides, which would be the whole thing. And you cannot break this apart. You have to do everything that's underneath the square root, unless it's multiplying. All right, it's just how the square root works that you can't break it apart like that. Does that kind of answer your question? Okay. Yeah, you can't break it apart. It has to be the whole thing. All right, other questions? Okay. All right, using even odd identities, we've already talked about these. This just puts it more concrete and actually puts a little section of it because it's going to be a big chunk of your homework being able to do this. The homework before told you to put it in sine and cosine and then simplify. That was kind of an easy breaking off point for you guys. What's going to happen from now on is it's usually just going to say simplify. And one of the first steps of simplifying is to get rid of negative signs that are inside the parenthesis. In order to do that, either we're going to bring it out front, or it's just going to disappear. Well, if you have sine, if you look at your unit circle and you find sine of 30 degrees equals 1/2, and I look at sine of negative 30 degrees equals negative 1/2. That means sine of negative x is the exact same thing as if I just put a negative sign on the front of it. So negative sine of x. And if I go to that table, I can just fill this in as negative sine of x. And cosecant is reciprocal, so it's going to follow the same rules, that it'll be negative cosecant of x. All right, cosine of negative x. If I take the cosine of 60 degrees, it equals 1/2. The cosine of negative 60 degrees is also 1/2. So whether I have a negative in here or not, it's going to be the exact same answer. So on this one, the negative sign is just going to kind of disappear. It'll be the exact same answer. So once again, I go to that box, and we'll have cosine of x. And we're going to have secant of x. The same rule applies to secant. Tangent works a lot like sine, where the negative just comes outside. So we have negative tangent x, and cotangent will be negative cotangent of x. So when I ask you to simplify, the first thing you need to do is get rid of any negatives that are in there. That'll be one of the big steps. So you have to remember which one gets pulled out front and which one just kind of disappears. All right, so as example, I'm supposed to simplify sine of negative x cotangent of negative x. We need to get rid of those negative signs. That'll be our first step. So we're going to go ahead and rewrite this. Well, for sine, I can bring the negative sign outside, so we can assign negative sine of x. And for cotangent, I can bring the negative out front as well. So I have negative cotangent of x. Well, a negative times a negative is a positive, so it's just going to be sine of x cotangent of x. I know I can rewrite cotangent in terms of cosines and sines, so I'm going to go ahead and do that. I'm going to rewrite this as sine of x times, now cotangent has cosine on top, so cotangent has cosine on top, so it'll be cosine x divided by sine of x. My sines will cancel out, and we'll just be left with cosine of x. And that's as simplified as I can possibly make it. But we couldn't do any of that with those negatives in there because we don't have any trig identities that have negative x values. So we need to get the negatives out first. Any questions on that? No? These should be pretty easy to set up to start off with. It's just how to simplify after. There should be the hard part. Okay. Prove an equation is not an identity. In order for an identity to be an identity, it must be true for every single value. That's what makes it an identity. So that being said, all we have to do is find one example that's false, and it's no longer an identity. So all we need to find is one example that is false, and we prove something's not an identity. And a lot of these are just going to be trial and error. You're just going to kind of pick values that might work, check them out, see if they work or not. So for this one, I need to show that sine of 2t is not equal to 2 sine of t. I know the answer, so our first guess is going to work, but I'm basically just grabbing any angle. All right, I'm just picking any old angle, and I'm going to see if it disproves it. All right, the better we get at these, the easier it is to see which ones aren't going to work there. But on just starting off, it's just kind of trial and error. Hey, Will, can you pick up your head, please? Thank you. All right, so we're just going to plug that into these two equations. So I'll plug that in there and there. So we're going to have sine of 2 times pi over 4. And we're going to see if that's equal to 2 times sine of pi over 4. Which would be awesome because that would be an easy thing to use. It's not true, but... Alright, so simplifying this, I have sine of pi over 2. And that's going to equal... Well, what's sine of pi over 4? Who could tell me sine of pi over 4? If you don't know, you should probably be looking at your unit circle because this will pop up. Square root of 2 over 2. So although we won't be using the unit circle as much, these things can pop up. Which means those cancel out. The sine of pi over 2, that one's easy because that's straight up. That's just going to be 1. Does 1 equal square root of 2? I'm going to say no. That means this is false. I found one example where it's not true, so that guy is false. All right, it's just one example. There's none of this in your homework. It'll be homework the next time we have homework, and I'll bring it up. But in this exact homework, we don't have an exact example of this, but the later one will. Any questions of anything we did today? All right, things like this, they shouldn't be overly difficult. It should be pulling out the negative and simplifying like we did in the last homework. But then you have 3 problems that are like this. Just remember, I only picked this one because I knew the tangent value. You might use one of the other 3 depending on which value is given to you. All right, let's go ahead and get started